Osmo E is short for osmotic electricity. Imagine a renewable energy capable of producing energy 24 hours a day, 7 days a week. One might think hydroelectrical plant. But now imagine it can be placed anywhere without the restrictions of needing running water, and with the capacity of it being scalable to fit the need of the amount of energy one wants to produce. This is what Osmo E can provide. Clean, renewable energy 24/7. Osmo E is like a mini hydroelectrical plant without the need of running water. Here, water instead cycles through interconnected pipes with the help of the laws of physics, such as osmosis, gravity, and Poiseuille's law, mimicking how the blood circulates through the cardiovascular system in the human body. When I think of osmosis, I think of a lab experiment, of a glass box full of water separated by a semi-permeable membrane. Each compartment, A and B, has a different concentration of solute dissolved in the water. Osmosis is the process by which water moves through the semi-permeable membrane from the compartment of high concentration of water to low concentration of water. But since the membrane only allows water to go through it and not the solute, the concentration of solute remains different between the compartments. As a result, the force of osmosis pulls the water from high to low concentration of water, causing the volume of one compartment to be larger than the other until the concentration of water is at equilibrium on both sides of the membrane. Now keep in mind, there's another way to describe this process. You see, the solution with the little amount of solute is considered a less concentrated solution, thus has a high concentration of water. And the solution with a large amount of solute is considered to be more concentrated solution, thus has a low concentration of water. One can say then that osmosis is the motion of water flowing through a semi-permeable membrane from low to high concentration of solute in the solution. Reverse osmosis, on the other hand, is the force that pulls water in the opposite motion as osmosis and only works under special conditions. Reverse osmosis is the motion of water through a semi-permeable membrane that allows flow of water from low to high concentration of water under certain conditions where the hydrostatic pressure is greater than the osmotic pressure. Remember, osmosis was the motion of water through a semi-permeable membrane from high to low concentration of water. The size of the solute determines the size of the pores of the selected reverse osmotic membrane. In Osmo E, the cross-flow reverse osmotic membranes can be nanofiltration, ultrafiltration, or microfiltration. Which reverse osmotic membrane to use will depend on the solute that is used based on cost-efficacy models. Poiseuille's law describes the flow of a fluid as being directly proportional to the change in pressure and the fourth power of the radius, and inversely proportional to the length of the tube and the viscosity. Thus, the variation in the radius of the interconnected tubes in Osmo E will also determine the flow of the water. Because the radius affects the flow, this will affect the hydrostatic pressure buildup that will be key to allow the cycling of the water within the interconnected tubes. In Osmo E, the slanted tube is the head. At the end of the head, the water turbines are located to generate electricity as water flows through them. In the head, the reverse osmotic membrane separates the compartment into impure compartment, or I compartment, and pure compartment, or P compartment. The solute of the solution will remain in the impure compartment and in the tube labeled A and E, while the pure compartment, as the name suggests, should remain pure water without solute. Past the turbine, an osmotic membrane separates the pure and the impure compartment. Once osmosis occurs, as well as with the help of the variation in the radius of the tubes per Poiseuille's law, enough hydrostatic pressure should push the water through point E and back to point A, where the cycle should repeat itself once more. Osmo E is scalable. Its minimal size of the head should be no less than 3 meters long, so that a strong enough flow is created by gravity to hit the turbines and produce a significant amount of energy. Otherwise, it will simply not produce a significant amount of energy. But the maximum size has no such limitations and can even be built the size of a building. Osmo E can be small enough, as long as the head is at least 3 meters long, to fit a room or the top of a rooftop to supply apartments. Ideally, Osmo E should be installed with a micro smart grid, along with other renewable energy sources, and serve as a reliable adjuvant of energy sources to alternate power sources and lessen the demand for energy at homes, buildings, or small communities.